This is a glossary of terms that are or have been considered areas of study in mathematics. A. Absolute differential calculus. The original name for tensor calculus developed around 1890. Absolute geometry, an extension of ordered geometry that is sometimes referred to as neutral geometry, because its axiom system is neutral to the parallel postulate. Abstract algebra, the study of algebraic structures and their properties. Originally it was known as modern algebra. Abstract analytic number theory, a branch mathematics that take ideas from classical analytic number theory and applies them to various other areas of mathematics. Abstract differential geometry, a form of differential geometry without the notion of smoothness from calculus. Instead it is built using sheaf theory and sheaf cohomology. Abstract harmonic analysis, a modern branch of harmonic analysis that extends upon the generalized Fourier transforms that can be defined on locally compact groups. Abstract homotopy theory. Additive combinatorics, the part of arithmetic combinatorics devoted to the operations of addition and subtraction. Additive number theory, a part of number theory that studies subsets of integers and their behavior under addition. Affine geometry, a branch of geometry that is centered on the study of geometric properties that remain unchanged by affine transformations. It can be described as a generalization of Euclidean geometry. Affine geometry of curves, the study of curves in affine space. Affine differential geometry, a type of differential geometry dedicated to differential invariance under volume preserving affine transformations. Alphas theory, a part of complex analysis being the geometric counterpart of Nevinlinear theory. It was invented by Lars Alphas. Algebra, a major part of pure mathematics centered on operations and relations. Beginning with elementary algebra, it introduces the concept of variables and how these can be manipulated towards problem solving, known as equation solving. Generalizations of operations and relations defined on sets have led to the idea of an algebraic structure which are studied in abstract algebra. Other branches of algebra include universal algebra, linear algebra and multilinear algebra. Algebraic analysis, motivated by systems of linear partial differential equations. It is a branch of algebraic geometry and algebraic topology that uses methods from sheaf theory and complex analysis to study the properties and generalizations of functions. It was started by Mikio Sato. Algebraic Combinatorics, an area that employs methods of abstract algebra to problems of combinatorics. It also refers to the application of methods from combinatorics to problems in abstract algebra. Algebraic computation, see symbolic computation. Algebraic geometry, a branch that combines techniques from abstract algebra with the language and problems of geometry. Fundamentally, it studies algebraic varieties. Algebraic graph theory, a branch of graph theory in which methods are taken from algebra and employed to problems about graphs. The methods are commonly taken from group theory and linear algebra. Algebraic K-Theory, an important part of homological algebra concerned with defining and applying a certain sequence of functors from rings to abelian groups. Algebraic number theory, a part of algebraic geometry devoted to the study of the points of the algebraic varieties whose coordinates belong to an algebraic number field. It is a major branch of number theory and is also said to study algebraic structures related to algebraic integers. Algebraic statistics, the use of algebra to advance statistics. Although the term is sometimes restricted to label the use of algebraic geometry and commutative algebra in statistics. Algebraic topology, a branch that uses tools from abstract algebra for topology to study topological spaces. Algorithmic number theory, also known as computational number theory, it is the study of algorithms for performing number-theoretic computations. Abelian geometry, an area of study based on the theory proposed by Alexander Grothendieck in the 1980s that describes the way a geometric object of an algebraic variety can be mapped into another object without it being an abelian group analysis, a rigorous branch of pure mathematics that had its beginnings in the formulation of infinitesimal calculus. The classical forms of analysis are real analysis and its extension complex analysis, whilst more modern forms are those such as functional analysis. Analytic Combinatorics, part of Enumerative Combinatorics, where methods of complex analysis are applied to generating functions. Analytic Geometry, usually this refers to the study of geometry using a coordinate system. Alternatively, it can refer to the geometry of analytic varieties. In this respect, it is essentially equivalent to real and complex algebraic geometry. Analytic Number Theory, part of number theory using methods of analysis. Applied Mathematics, a combination of various parts of mathematics that concern a variety of mathematical methods that can be applied to practical and theoretical problems. Typically, the methods used are for science, engineering, finance, economics and logistics. Approximation theory, part of analysis that studies how well functions can be approximated by simpler ones. Array-glove geometry, also known as array-glove theory. Array-glove theory, an approach to Diophantine geometry used to study Diophantine equations in higher dimensions. It is named after Shaw and array-glove. Arithmetic. To most people this refers to the branch known as elementary arithmetic dedicated to the usage of addition, subtraction, multiplication and division. However, arithmetic also includes higher arithmetic, referring to advanced results from number theory. Arithmetic algebraic geometry. See arithmetic geometry. Arithmetic Combinatorics, the study of the estimates from combinatorics that are associated with arithmetic operations such as addition, subtraction, multiplication and division. Arithmetic Dynamics. Arithmetic Geometry, the study of schemes of finite type over the spectrum of the ring of integers. Arithmetic Topology, a combination of algebraic number theory and topology studying analogies between prime ideals and knots. Arithmetical algebraic geometry, an alternative name for arithmetic algebraic geometry. Asymptotic combinatorics. Asymptotic geometric analysis. Asymptotic theory, the study of asymptotic expansions. Oslinder-Riemann theory, the study of the representation theory of Artinian rings. Axiomatic geometry, see synthetic geometry. Axiomatic homology theory. Axiomatic set theory, the study of systems of axioms in a context relevant to set theory and mathematical logic. Bifurcation theory, the study of changes in the qualitative or topological structure of a given family. It is a part of dynamical systems theory. Birational geometry, a part of algebraic geometry that deals with the geometry that is dependent only on its function field. Beaulier-Lobachevskian geometry, see hyperbolic geometry. See algebra theory. Cartesian geometry, see analytic geometry. Calculus, a branch usually associated with limits, functions, derivatives, integrals and infinite series. It forms the basis of classical analysis, and historically was called the calculus of infinitesimals or infinitesimal calculus. Now it can refer to a system of calculation guided by symbolic manipulation. Calculus of infinitesimals, also known as infinitesimal calculus. It is a branch of calculus built upon the concepts of infinitesimals. Calculus of moving surfaces, an extension of the theory of tensor calculus to include deforming manifolds. Calculus of variations, the field dedicated to maximizing or minimizing functionals. It used to be called functional calculus. Catastrophe theory, a branch of bifurcation theory from dynamical systems theory, and also a special case of the more general singularity theory from geometry. It analyzes the germs of the catastrophe geometries. Categorical logic, a branch of category theory adjacent to the mathematical logic. It is based on type theory for intuitionistic logics. Category theory, the study of the properties of particular mathematical concepts by formalizing them as collections of objects and arrows. Chaos theory, the study of the behavior of dynamical systems that are highly sensitive to their initial conditions. Character theory, a branch of group theory that studies the characters of group representations or modular representations. Class field theory, a branch of algebraic number theory that studies abelian extensions of number fields. Classical differential geometry, also known as Euclidean differential geometry. See Euclidean differential geometry. Classical algebraic topology. Classical analysis usually refers to the more traditional topics of analysis such as real analysis and complex analysis. It includes any work that does not use techniques from functional analysis and is sometimes called hard analysis. However, it may also refer to mathematical analysis done according to the principles of classical mathematics. Classical analytic number theory. Classical differential calculus. Classical Diophantine geometry. Classical Euclidean geometry. See Euclidean geometry. Classical geometry may refer to solid geometry or classical Euclidean geometry. See geometry. Classical invariant theory, the form of invariant theory that deals with describing polynomial functions that are invariant under transformations from a given linear group. Classical mathematics, the standard approach to mathematics based on classical logic and ZFC set theory. Classical projective geometry. Classical tensor calculus. Clifford analysis, the study of Dirac operators and Dirac-type operators from geometry and analysis using Clifford algebras. Clifford theory is a branch of representation theory spawned from Clifford's theorem. Cobordism theory. Cohomology theory. Combinatorial analysis. Combinatorial commutative algebra, a discipline viewed as the intersection between commutative algebra and combinatorics. It frequently employs methods from one to address problems arising in the other. Polyhedral geometry also plays a significant role. Combinatorial design theory, a part of combinatorial mathematics that deals with the existence and construction of systems of finite sets whose intersections have certain properties. Combinatorial game theory. Combinatorial geometry, see discrete geometry. Combinatorial group theory, the theory of free groups and the presentation of a group. It is closely related to geometric group theory and is applied in geometric topology. Combinatorial mathematics. Combinatorial number theory. Combinatorial set theory, also known as infinitary combinatorics. See infinitary combinatorics. Combinatorial theory. Combinatorial topology, an old name for algebraic topology, when topological invariants of spaces were regarded as derived from combinatorial decompositions. Combinatorics, a branch of discrete mathematics concerned with countable structures. Branches of it include enumerative combinatorics, combinatorial design theory, matroid theory, extremal combinatorics and algebraic combinatorics, as well as many more. Commutative algebra, a branch of abstract algebra studying commutative rings. Complex algebra. Complex algebraic geometry, the mainstream of algebraic geometry devoted to the study of the complex points of algebraic varieties. Complex analysis, a part of analysis that deals with functions of a complex variable. Complex analytic dynamics, a subdivision of complex dynamics being the study of the dynamic systems defined by analytic functions. Complex analytic geometry, the application of complex numbers to plane geometry. Complex differential geometry, a branch of differential geometry that studies complex manifolds. Complex dynamics, the study of dynamical systems defined by iterated functions on complex number spaces. Complex geometry, the study of complex manifolds and functions of complex variables. It includes complex algebraic geometry and complex analytic geometry. Complexity theory, the study of complex systems with the inclusion of the theory of complex systems. Computable analysis, the study of which parts of real analysis and functional analysis can be carried out in a computable manner. It is closely related to constructive analysis. Computable model theory, a branch of model theory dealing with the relevant questions computability. Computability theory, a branch of mathematical logic originating in the 1930s with the study of computable functions and Turing degrees, but now includes the study of generalized computability and definability. It overlaps with proof theory and effective descriptive set theory. Computational algebraic geometry. Computational complexity theory, a branch of mathematics and theoretical computer science that focuses on classifying computational problems according to their inherent difficulty, and relating those classes to each other. Computational geometry. Computational group theory, the study of groups by means of computers. Computational mathematics, the mathematical research in areas of science where computing plays an essential role. Computational number theory, also known as algorithmic number theory, it is the study of algorithms for performing number-theoretic computations. Computational real algebraic geometry. Computational synthetic geometry. Computational topology. Computer algebra, see symbolic computation. Conformal geometry, the study of conformal transformations on a space. Constructive analysis, mathematical analysis done according to the principles of constructive mathematics. This differs from classical analysis. Constructive function theory, a branch of analysis that is closely related to approximation theory, studying the connection between the smoothness of a function and its degree of approximation. Constructive mathematics, mathematics which tends to use intuitionistic logic. Essentially that is classical logic but without the assumption that the law of the excluded middle is an axiom. Constructive quantum field theory, a branch of mathematical physics that is devoted to showing that quantum theory is mathematically compatible with special relativity. Constructive set theory. Contact geometry, a branch of differential geometry and topology, closely related to and considered the odd-dimensional counterpart of symplectic geometry. It is the study of a geometric structure called a contact structure on a differentiable manifold. Convex analysis, the study of properties of convex functions and convex sets. Convex geometry, part of geometry devoted to the study of convex sets. Coordinate geometry, see Analytic Geometry. CR geometry, a branch of differential geometry, being the study of CR manifolds. Derived non-commutative algebraic geometry. Descriptive set theory, a part of mathematical logic, more specifically a part of set theory dedicated to the study of Polish spaces. Differential algebraic geometry, the adaptation of methods and concepts from algebraic geometry to systems of algebraic differential equations. Differential calculus, a subfield of calculus concerned with derivatives or the rates that quantities change. It is one of two traditional divisions of calculus, the other being integral calculus. Differential Galois theory, the study of the Galois groups of differential fields. Differential geometry, a form of geometry that uses techniques from integral and differential calculus as well as linear and multilinear algebra to study problems in geometry. Classically, these were problems of Euclidean geometry, although now it has been expanded. It is generally concerned with geometric structures on differentiable manifolds. It is closely related to differential topology. Differential geometry of curves, the study of smooth curves in Euclidean space by using techniques from differential geometry. Differential geometry of surfaces, the study of smooth surfaces with various additional structures using the techniques of differential geometry. Differential topology, a branch of topology that deals with differentiable functions on differentiable manifolds. Diffie theory. Diophantine geometry, in general the study of algebraic varieties over fields that are finitely generated over their prime fields. Discrepancy theory. Discrete computational geometry. Discrete differential geometry. Discrete dynamics. Discrete exterior calculus. Discrete geometry. Discrete mathematics. Discrete Morse theory, a combinatorial adaptation of Morse theory. Distance geometry. Domain theory. Donaldson theory, the study of smooth-form manifolds using gauge theory. Dynamical systems theory. Econometrics, the application of mathematical and statistical methods to economic data. Effective descriptive set theory, a branch of descriptive set theory dealing with set of real numbers that have light-face definitions. It uses aspects of computability theory. Elementary algebra, a fundamental form of algebra extending on elementary arithmetic to include the concept of variables. Elementary arithmetic, the simplified portion of arithmetic considered necessary for primary education. It includes the usage addition, subtraction, multiplication and division of the natural numbers. It also includes the concept of fractions and negative numbers. Elementary mathematics, parts of mathematics frequently taught at the primary and secondary school levels. This includes elementary arithmetic, geometry, probability and statistics, elementary algebra and trigonometry. Elementary group theory, the study of the basics of group theory. Elimination theory, the classical name for algorithmic approaches to eliminating between polynomials of several variables. It is a part of commutative algebra and algebraic geometry. Elliptic geometry, a type of non-Euclidean geometry and is based on spherical geometry. It is constructed in elliptic space. Enumerative combinatorics, an area of combinatorics that deals with the number of ways that certain patterns can be formed. Enumerative geometry, a branch of algebraic geometry concerned with counting the number of solutions to geometric questions. This is usually done by means of intersection theory. Equivariant non-commutative algebraic geometry. Ergodic-Ramsey theory, a branch where problems are motivated by additive combinatorics and solved using ergodic theory. Ergodic theory, the study of dynamical systems with an invariant measure, and related problems. Euclidean geometry. Euclidean differential geometry, also known as classical differential geometry. See differential geometry. Euler calculus. Experimental mathematics. Extraordinary cohomology theory. Extremal combinatorics, a branch of combinatorics. It is the study of the possible sizes of a collection of finite objects given certain restrictions. Extremal graph theory.